folks, I would like to make a video on synthesis at 3D left and 2-2. Let's look at problem 9 first. Okay. Let me say this problem 9 says that we have to find all complex numbers z such that the absolute value of z will be equal to 1 and the absolute value of z squared plus the conjugate of z to the power 2, and those conjugate must give me 1. I must find all the complex numbers z such that this guy is equal to that one there. Okay, now there's a lot. We can do it in many ways, but you have just to use some ways that is actually convenient to us. Okay, now be patient with this software so that we can actually start working. But it will be easier for us to just write z in exponential form. Okay, just write z in exponential form. Let's see, take this one. Because I can't see that. Therefore, if I write it in exponential form, I will have, let's say z is equal to 1. Okay, that is your thing, e to the power j theta. Okay, that's the same situation. Okay, that means that the modulus of z is equal to 1, and I'll have an argument that is equal to cosine theta. Therefore, I just say this is equal to cosine plus j sine theta. This is one way to write your complex number. It will be much more easier to find the z squared or all the things. But by doing that, I know that my conjugate will be equal to cos theta plus minus j sine theta. Okay, that's a nice one there. And then they're just asking us to find, now just have to find z to the power 2 plus z, the conjugate of z. Okay, the conjugate of z, all this to the power 2. Nonsense. It's different. That one to the power 2. Okay, therefore I'll have, for the first one, I'll have cos squared theta minus sine squared theta plus 2j sine theta cos theta. Okay. This is the same as saying that I have this quantity, but I won't do it now, plus cos squared theta plus minus sine squared theta lovely, sorry folks, sine squared theta lovely, and minus 2j sine theta and cos theta. Okay, no, that's what we have there. Now, my complex number will be yourself if this monitor is ready to set up the monitor correctly. For this quantity will be equal to, for this one, this term here, and simplify this term. Sorry folks. This one and that one will give me 0. And I end up with 2 cos 2 theta. But you know that cos squared minus sine squared is equal to cos 2 theta. You know that formula. And then there are 2 there, therefore will be equal to 2 theta there. Now, the absolute value of this quantity must give me 1. Okay. Now, the absolute value of this quantity will be equal to 2, because the absolute value of a real number is always that number, because this is a real number anyway. If I have cos 2 theta, must give me 1. Okay. Is it 1? Yes, it must give you 1. Okay, therefore I end up with cos 2 theta will be equal to a half. Lovely. And then the cosine that gives me a half will be the 60 degrees. That means that we have pi. This is the same as pi over 3. 60 degrees pi over 3. And then I have to add plus 2 with the cycle there. Okay, this is my thing there. Therefore, 2 theta, that's our first case anyway. 2 theta will be equal to pi over 3 there, multiply by that one, plus 2k pi, lovely. And then theta, that is theta 1, because there will be 2 possibilities, that theta 1 will be equal to pi over 6, that's pi over 6, and plus pi there, lovely. Put everything in. Okay, this is one possibility, because I like that. Okay, and in this case here, k is given by k will be equal to 0, because k is an integer, because we didn't really address k. You can say that k is an integer, and like that would, I don't know why I have to enumerate a set, but let me enumerate a set anyway. We have negative part there, okay, negative numbers, then I'll let start by minus 2, minus 1, 0, 1, 2, and then okay, until the biggest value as an integer there. Okay, I can see that this is a subset of z. Okay, or this subset, or it can be equal to z. Okay, that's one of the possibilities. Now the second possibility is just to take the negative side there. I can say that is cosine 2 theta. I can go to the fourth quadrant, is equal to minus pi over 6, pi over 3. Oh. Okay, plus another cycle there. Lovely. Then now there's this is minus pi. So lovely. Then we will carry on now. That's the cosine function is a 1-to-1. Then I don't think it's a 1. It's not a 1-to-1. But let's say that if the output is equal, therefore the input must be equal. Yeah, it's not really good because we have a cycle, but you can see that there is my cycle there. And then theta there will be equal to this is the second set of solution. Okay, and we'll have pi over 6 there. And then for this one we'll do pi. Lovely. And everything is sorted now. Remember that k is a subset of that quantity. And that's it. The subset of z, or the number of, is just a integer there. Okay. You can also just put a half here, and then is equal to that quantity. Okay, lovely. Now I can say that my complex number, we can have two sets of complex number there. Yeah, z1 will be equal to e to the power pi over 6. Pi over 6 plus say plus k pi k pi there. That's a set, and all these I can put there is my. This is not the right one. It's not what I want. And I'll put my j there. Lovely. And then you can see that I have my things there. And my complex number. Complex number will be equal to cos. Oh, we have quite a lot of them. There is a family of complex numbers, not even one. There is quite a lot. And the second one is same solution there. I wanted to put in a rectangular form. That's why I'm going to do a bit. Let me put everything in an example of those complex numbers. Now you can see that there will be quite a lot of complex numbers there. I will take z is equal to, if k is equal to 0, I'll have cos of pi over 6, that is cos of 30 degrees. I know that cos of 30 degrees is square root of 3 over 2. Okay, and plus, this is the case where k is equal to 0, or plus j sine of half, okay, say half j over 2. Okay, that's the first one. The second one will be if I put on if k is equal to 1, I'll have I'm going to the second quadrant, not the third quadrant, sorry. And the third quadrant, everything is negative. Okay. Second quadrant, the real part, the third quadrant, the real part and the imaginary part are negative. Okay. And then when you say that k is equal to 2, I end up with this complex number. Now if I say k is equal to, let's say k is equal to 3, I end up with this complex number. If k is equal to, well, you can see that it is circle between these two complex numbers. Okay, therefore I can safely say that this is first one and I'll have the second one here. Okay, now let's just not to avoid any confusion, let's just put, I just want to put because the family of complex numbers, you can just put a p there, and then this one will be a q. I will put a q. Let's see what that will give me. Okay, therefore I just put it in my rectangular form. Okay, lovely. Then for z3 will be equal to, and then in this case I'll have, if k is equal to 0, I'll have, of course, for minus pi over 6, that is I'll end up in the fourth quadrant. In the fourth quadrant, your real part is negative and your real part is positive, and your imaginary part is actually negative. Okay, I end up with this complex number. Now, if k is equal to 1, then everything becomes negative. This one will change the sign, and then the imaginary part will also change the sign there. Okay, therefore z4 will be equal to minus that. Let's see, can put this one, and then will be equal to this quantity, and this one will be positive. Okay, and then this is the two possibilities that we can actually have, because if we say that k is equal to 2 and we end up in this situation, k is equal to 3, I end up with that one, and then we swap between the two variables. Therefore I'll have four complex numbers, okay, that really satisfy that condition. Okay, thank you. This is how you solve the problem 9. Thank you. Lovely.